And we're back at it again for another day. As you can see here, this is called surface area part two, or part two. We're going to continue on what we were talking about in the previous lesson and go a little bit more in depth with it this time. As you know, I would never give you stuff that easy, so let's step it up a notch and try some more difficult stuff. Let's carry on then right from where we left off. We're trying to find the surface area, which is the area of each panel of a three-dimensional shape. If you're not 100% sure, this is a three-dimensional shape. It's made up of two triangles. In this case, they're right triangles. Those are these in red. And the other panels, the bottom is just a rectangle. It looks like a parallelogram, but that's just because of the three-dimensional shape here. The back panel is also a rectangle. It's vertical up and down. And then there is a giant, it's the hypotenuse side, which is there, there, and there. So it's three big panels and then two triangles on the ends. Remember, the formula for the area of a triangle is half the base times the height. In this case, the base is 10, as it says right here, and the height is 11. 10 times 11 is 110, and half of that, because we got to do half of base times height, is 55 and 55. The bottom is 20 times 10. 20 times 10 is 200. I'm going to write them right in the spot. The back panel, the vertical one that goes up and down, is 11 by 20. So that's 220. That would be the back panel. And then the front panel is 15 by 20. So that would be 300. So our five faces here are 300, 220, 200. Those are all the rectangles, plus the front and backs of 55. And then we would add that up and get a total. I'm not even going to bother adding them all up. That's just what you would do. This is unusual. This is a parallelogram. It's also a prism. I don't know how you would say that. A parallelogram prism or a parallelogram prism. Notice that it has to give you this important information, which is the height of the parallelogram. And it says at the top here, this is 13 because it says it's 13 here. So this is the same thing. The front and back are going to be parallelograms, but all four of the other sides are just rectangles. And the rectangles have these dimensions, 25 by 7, etc. So let's first find the front and back parallelograms, which is 13 times 6, which is basically 60 plus 18. So that would be 78. And 78 as the front and back of this shape. The sides are all parallelograms, like I said, and so are the bottoms. So let's go 25 by 7. And I know some of you are thinking that's an angle. It looks like it's on an angle. But really, if you think about it, if the front is tipped, the sides are still rectangles. And it's a 7 by 25 rectangle. So 25 times 7, you can do that on your calculator. If you need to, it's 175. And same with this side, 175. They're twins. And then the top and bottom would be just 13 by 25. So 13 times 25, I think 12 25s would be 300. So 325 on the top and bottom. It's hard to write in top and bottom, but we have a top. So I would just add them all up. 325, 325, 175, 175. Those are the two sides, and the front and back are 78 and 78. Add them all up, and you're going to get the total of this parallelogram prism. Again, I'm not going to add them all up because that's too painful for me. Let's just move on. If you remember, we're trying to find the area because we're going to be faced with a hexagon prism. And I know you're thinking, oh my God, that is ugly. but it's doable. We just got to remember how to find the area of a pentagon or any polygon, which is just to make triangles out of it. And remember, the apothem is the height of the triangle. In this case, the triangle would look like this. And the apothem is 8. The base is 10. That'd be 10 times 8, which is 80, divided by 2 because it's a triangle. So it would be 40. This is 40. This triangle is 40. This triangle is 40. This triangle is 40. And this triangle is 40. That's 5 triangles of 40. 5 times 40. This would have 200 centimeters squared as our area. Remember that from last unit. Some of you might have forgotten. So again, this is a hexagon. You can make it into 6 identical triangles. Just find, oh, that's not very pretty, but just find the height or the area of one of the triangles, and then you're good to go. Right? You can do that. It's 14 times 8 divided by 2, which would be 56 centimeters squared. And then times that by 6, because they're all 56. All right. So we could easily find the area. That would be 56 times 6. And if you're not sure what that is, use your calculator, 336. All right, so let's try that as a question. We're trying to find the surface area of this pentagonal prism. So it's a pentagon in the front, pentagon in the back, and all the sides are rectangles. So if we flatten this out, we're going to have 7 sides. The 5 sides that are all identical, and the front and back. So I don't know what we want to work on first. Why don't we find the area of this pentagon? So the distance to the height, the apothem, is 6, it says, and the base is 9. So 6 times 9 divided by 2. 6 times 9 is 54, and half of 54 is 27. So using half area is a half base times height. That's from last unit. That's half of 6 times 9. And 6 times 9 is 54. Half of 54 is 27. That's where I got that number. This area is 27, and there are 5 identical triangles. So I'm going to do 27 times by 5. And the front area is 135. So is the back. So I'm going to start my surface area at 135 plus 135. Now I just need to find the rectangles on the side, and that should be easy because they are 30 by 9. And 30 times 9, 9 times 3 is 27. Add a 0, I have 5 identical panels that are all 270. And there's one more that you can't see, but it would be the roof on the other side here. So I have 570. In fact, I could just write that out times by 5. I'll put an X in there so it doesn't look like a decimal. So I'm going to do 570 times by 5, which is 2850. Again, that's all 5 of the panels, plus the front and back of 135 each. And I get 3120. That's my total surface area, centimeters squared. Whew, that's tough. Now we're probably going to get into some more difficult stuff. Here we've got a box with a triangular prism on top. To find the surface area of this, we're going to have to find each panel separately and add them together. Now this looks confusing and daunting, but it's not. There's front, back, there's a bottom, there's a top, and there's an inside panel where the top meets the bottom, but we don't need to worry about that. So let's break this down into a bunch of shapes. First, let's deal with this rectangle right here at the front. It is 12 times 8, which is 96. This back one is also 96. I'm going to find this little triangle next, which is 5 by 8 divided by 2. 5 times 8 divided by 2. 5 times 8 is 40. Half of that is 20. All right, so this entire front panel is 96 and 20. 96 plus 20 is 116. That's the front panel. This back panel is the same size. 116. Then I'm just going to find the remaining rectangles. So I'm going to erase that just so that it doesn't confuse us. And let's look at the bottom panel, which is 8 by a length, and it's just a rectangle. And the length is 20 because that's the depth of the shape. So it's 8 across and 20 deep. I know it's 20 because this says 20 up here. So 20 times 8 is 160. That bottom panel is 160. And add that. Okay, so we've got that. All right, then let's look at this. I'm going to erase that, get it out of the way. Let's look at this giant panel that goes all the way down, all the way up, and all the way up to here. It's a big rectangle. This is 12, which means this height is 12 from here to here, but it's also 5 here. So I'm going to add those together. That makes 17. So the height of this thing is 17, which is this length right here. And I'm going to times it by the depth of 20. That'll give me this giant panel all in one calculation. So 17 times 20, use your calculator if you need to, is 340. All right, so I'm going to erase that so as we're not confused by it. Get rid of all that. That didn't work. Try it again. All right, so we've got 4 of the panels down: the front, the back, the bottom, and the giant one. Okay, so we need to calculate, let's see, like this one right here. Kind of the right-hand side of the shape. It's 12 by 20. 12 by 20 is 240. Okay, that's another side we've done. That's pretty simple. Length times width. We're going to need to find the roof, which is this here. That's 20 times by 9, which is 180. Whew. And is that it, I wonder? I think that might be it. It might be all the sides we need. So we've got the front, back, bottom, roof. Yeah, 1, 2, 3, 4, 5, 6 sides we should have, and it looks like we do. So we'll add them all up, and that should give us the total surface area of this shape. Remember that we do not need this one here in the middle because it's in the middle of the shape, and the surface area only includes the stuff on the outside of this. We don't have to worry about the ones in the middle. And in fact, in this case, I don't know if there actually is one in the middle. I guess let's add that up just for fun. That's 160, that's 340 plus 240. No, you know what, let's not. All right, that is the end of, again, part 2. Today's worksheet is going to be similar to yesterday, but a little bit more difficult. It's going to have a little bit more complex shapes. Again, it's the same concept. Break it down into individual surfaces, find the area of each surface using the formulas that you already know from last unit, and then total them all up. All right, good luck.